Welcome to topic 7 of C234 Mechanics of Deformable Bodies. We have flange bolt coupling. So the principle for this topic is that in shaft connection called the flange bolt coupling, the torque is transmitted by the shearing force P created in the bolts that is assumed to be uniformly distributed. So first, let us discover, or let me draw first the idea. So I'll draw a circle, and this will serve as the outside diameter of our flange. And right after that, let me draw another circle for the location of our bolts. And this crosshair, this crosshair will serve as the center of our shaft, this one. So if I'll draw an axis, to show the location for our bolts. So right now I'll be drawing our bolts. So let us assume there is a force P here, which is perpendicular with this axis, and another force P here, which is also perpendicular from the axis to the location of our bolt. So again, its principle is that the torque is transmitted by a shearing force P created in the bolts that is assumed to be uniformly distributed. So the formula for the torque for this one is that torque is simply equals to the shearing force P times the distance from the center of the shaft to the center of our bolt. So in the drawing, our distance is simply this one. So let us assume this as R. So times the distance times the number of our bolts. And we all know that since we are talking about here shearing force, so there exists a shearing stress. And we all know the very basic formula for stress is simply force over area. And that means that P, or the force, is simply equals to our stress times area. And we are talking about here for shearing stress, so that means we will use this variable. So with this, that means that our P is simply shear stress times the area of the bolt, resisting area of the bolt. So that gives us shearing stress times area times the distance times the number of bolts. Thus, it is the shear stress times the resisting area, which is the cross-sectional area of our bolt, pi over 4 times the diameter of the bolt square times R times N. So this is the formula of our torque. And what if in our flange bolt coupling there exist two concentric rows of bolts? So what I mean by two concentric rows of bolts, let me draw another circle here, which will give us the location of our bolts located in between the first set of bolts and in our center of the shaft. So here exists another set of bolts. Let me draw it here. Same assumptions. There exists a shearing force P, which is perpendicular with this line. So force P. So let me name this one as P1. Let me name this as P2. And we already have the distance from P1 to the shaft, which is R. So let me name this as R1. And for new distance here, this one, from P2 to the center of the shaft, let me name this as R sub 2. So now, the formula for our torque here, if we have two concentric rows of bolts, is simply summation of our force times the radial distance times N, or simply P1 times R1 times N1 plus P2 times R2 times N2. So for rigid flanges, the shear deformation in bolts are proportional to their radial distances from the shaft axis. So the shearing stress are related by first. So for ang balikon, the principle, shear deformation in bolts are proportional to the radial distances. So that gives us strain sub 1 over radial distance 1 is equals to strain sub 2 over R sub 2. And using Hooke's law, the shear modulus G is simply equal to the stress over strain. So we have here strain is simply equals to stress over G. And if we substitute the value of strain here, then we get, sorry for this one, then we get here the stress over G times the radial distance. So what I mean by that is it will give us strain 1, it gives us strain 1 over G1 times R1 is equals to stress sub 2 G2 times R2. And if we assume that the bolts have the same diameter, so it means that area 1 is simply equals to area 2, and if the bolts are made up of the same material, so they both have the same shear modulus, so G1 is equals to simply G2, then I can say that we can cancel out G sub 1 and G sub 2 because they both have the same materials used. And right now, since we have here the stress, and stress is simply equals to P over area, and if we assume that the bolts have the same area, so I can just simply neglect that stress is simply equals to P, and that gives us P sub 1 over R sub 1 is equals to P sub 2 over R sub 2. So this formula can be used if there are problem exists that you need to compute for the torque, not knowing the values for P1 and P2, but given the allowable shearing stress. So let us use this formula and this formula as well in our succeeding video tutorial on this topic.